So another aspect where you can find the application of dimension is to determine the formula of a physical quantity. So we're going to use this example to explain that. The velocity v of a wave in a stressed string depends on the tension T in the string and the mass per unit length mu of the string. Obtain an expression for v in terms of T and mu using the method of dimensions. So here we are told that v depends on, that is proportional to the tension T and also to mu. So what I'm going to do, I'm going to put values for this T raised to power A and mu raised to power B. You can choose any letters for this. So we tend to look for the value of A and what B so that we can get this formula. So here I can write this mathematically as V is equal to K T to the power of A and mu to the power of B. So V, the dimension of V is LT minus 1. That's velocity. And the dimension of T is the same as force. And we know that the dimension of force is LT ML. The dimension of force is MLT minus 2. Then we'll get the dimension of mu. Mu is mass per unit length, meaning that mass divided by length, and that will be ML minus 1. So we're going to put all of this in this equation here. So on the left hand side, the dimension of V, the speed, is LT minus 1. So I have LT minus 1 is equal to, so we have T to the power of A. So T is what? M. Okay, let me put the constant K. So I have M LT minus 2 raised to the power of A times, then mu is ML minus 1 raised to the power of B. So LT minus 1 is equal to K. So we just collect like terms from both of these. So this is going to be M to the power of A, L to the power of A, T to the power of 2 minus A. When you multiply this by this times M to the power of B. So B times minus 1 is L to the power of minus B. Okay. Next, we have LT minus 1 equals K. Just have to collect letters. So this times this will be M to the power of A plus B. L to the power of A times L to the power of minus B will be L to the power of A minus B. Then we'll have only one T here times T to minus 2A. So let's compare both sides. So we have to compare both sides. So by comparing on both sides, you find out that there is no M on this side. So we can write M to the power of 0, LT minus 1 is equal to K, M to the power of A plus B, L to the power of A minus B, T to the power of 2A. So I am putting 0 here because M raised to the power of 0 is 1. When you multiply by, we're back to this place. Okay. So let's compare now. So from here, we can compare this and this. So M to the power of 0 is equals to M to the power of A plus B. So this will cancel out this. A plus B is equal to 0. We can call this equation 1. We can also try this. We can try L to the power of 0 and this, but because this has just one term and this term here, so I can compare T to the power of minus 1 is equal to T to the power of minus 2A. So this will cancel out this. So I have minus 1 equals minus 2A. Minus cancel out minus. A equals 1 all over 2. So from here, I see that we can easily look for B from here. So from here, B will be equal to minus A. That's when you take this way. 0 minus A will be minus A. Hence, B is equal to A is 1 over 2, so that will be minus 1 over 2. So we will not need to be using this again because we only have two unknown A and B, which we have already worked out. So the next we'll have to do again is to go and put the value of A and B on this equation here. So I'll write that down again. V is equal to K T to the power of A mu to the power of B. Remember that this T is not time, but it is what? Force. Okay? So V will be equal to K. Now my T to the value of A is 1 over 2 times mu to the power of B, which is minus 1 over 2. And recall that from the laws of indices, A raised to power 1 over 2 is equal to square root of A, and A raised to power minus 1 over 2 is equal to 1 over square root of A. So we apply this to this. So V will be equal to K times T to the power of 1 over 2 square root of 2 of T rather, square root of T divided by or times this will be 1 over square root of mu. When we work this out, this will be V equals K root T all over, that's root T times 1 is root T all over root mu. And remember that for sort, root A over root B is the same as root A over B. So from here we can say that V is equals to K root T all over mu. So this is the formula obtained using dimensional analysis.